Hi guys, it's Miss DeLoss. We're looking at Unit 11, Skill 4, and it's all about statistical vocabulary or statistic vocabulary, but we're going to focus on three types of studies. We have a survey, an experiment, and that word says observation. I'm sorry, it's super messy. But there's a little article here relating those three key studies in stats, and I'd like for you to just read and annotate, highlight it as you go, and then I'll come back on here and explain what I've highlighted and why I've highlighted it and what's important about it. So take a minute, you're going to pause your video and do those things. Read, highlight, and annotate. Okay, so as you can see, I've got things in red, green, and blue. So first off, a survey is a study that asks questions from a sample population, and often that's referred to as a group, in order to learn more about the entire population. So there's two different groups. We have a sample population and we have the entire population. So if we do a survey, we're hoping to learn more about the entire population, because we're not going to survey the entire population. That's just too many people, depending on what the type of group is. Next, we have an experimental study. And so for this, individuals are always randomly assigned to two different treatment groups. It doesn't have to be two, it could be more than two, but to treatment groups in order to determine the effects of a treatment. So we've got this example here where we're talking about ibuprofen versus Tylenol. People were randomly separated into the two groups and asked to take a medicine, whether it was ibuprofen or Tylenol. They probably didn't know, and then they were asked to rate how well the headache symptoms were relieved. And then lastly, our observational study is where the sample population is just measured or data is gathered and analyzed, but you're not influencing the population in any way, and you're not intervening in the study. So you're just looking at data. So here we're still talking about that Tylenol and ibuprofen, and so what we did was we had 100 adults who regularly took headache medicine. So we didn't make them take it, they had already been taking it on the regular. And then we collected the data to see how the symptoms were relieved. So a couple key notes about observations versus experiments, because those are the two that often get mixed up the most. Treatment is imposed on an experiment, but not on an observation. You must randomly assign your participants to groups. It's forced assignment. You don't get to choose which group you're part of. But for an observation, you don't have to be randomly selected in order to go into a particular group. Often there's a control group, and what that means is that a group will maybe receive what's called a placebo, and I'm going to write that in here, placebo, which is like a sugar pill. It has zero effect on your body, but what they do is they give people in this control group a placebo, and they don't tell them that they have a placebo, and they're looking to see, is it a mind game or is it actual effect from the medicine? So when you take a placebo and you don't know, but yet you say your symptoms are resolved, it's a mind thing, okay? And then the last piece is very important. Observations cannot determine cause and effect, whereas experiments can determine cause and effect. And then lastly, a well-designed survey has zero bias. So what that means is that it has to be a random sample, and when it's not random, a bias is introduced, which may influence the study in favor of one outcome or another. So we have a couple Regents problems here, and we're going to just sort of work through each one. It says, which statement about statistical analysis is false? So it says things about experiments versus observations, and it says patterns, relationships, cause and effect, cause, effect, and then patterns and relationships. So as we just talked about, there's only one type that can determine cause and effect. So here, cause and effect is only ever determined by an experiment. In number 2, Cheap and Fast Gas Station is conducting a customer satisfaction survey. Which method of collecting would most likely lead to a biased sample? Biased again means like an unfair sample. I don't know what's up with my handwriting right now, but it's a mess. I'm so sorry. Okay, so number 2, our options are interviewing every 5th customer to come into the station, interviewing customers chosen at random, interviewing customers who call an 800 number, that's posted on their receipts, and then interviewing every customer who comes into the station on a day of the week chosen at random. So you'll notice that I underlined at random a couple times. That automatically means that we're likely not to have bias. So I'm going to get rid of that right away. And then the one that says interviewing every 5th customer, that's a systematic sample. And so we're going to actually get rid of that too, because if you are systematically sampling people, then you are reducing your bias. The last and final option is the people that are calling an 800 number. First off, it's posted on the customer's receipt. So if a customer does not look at their receipt, they're probably not going to call the 800 number. And then people that call an 800 number are the people that are either super happy with their customer service or super frustrated or upset by the customer service. So this would be only really strong opinions. And those really strong opinions then, of course, would be biased. Okay, so question 3, it says a random sample of 100 people that would best estimate the proportion of all registered voters in a district who support improvements to the high school football field should be drawn from voters in the district at A, and then they give us scenarios. So think about this, because remember that we want it to be random and systematic. For the best estimate of a proportion, again, it needs to be random or systematic. In other words, no bias. So if I were to interview people from a football game, you'd be like, oh yeah, everybody's going to support it. But remember, we want the best estimate. We don't want everybody saying yes to support the high school football field. We want there to be some no's in there, even though we might want the football field to be updated or whatever the vote is for. But there's bias in sampling at a football game because, yes, of course they want their field updated. So that one goes. Next, we have a school fundraiser. Anyone that is doing a school fundraiser is probably raising funds to make improvements school-wide, whether it's for a particular event at the school or a particular team or a club. Whatever it happens to do, you care about the school. So you probably have some bias. Even if you don't love football, you care about your school and you want to update probably the field. If we were to go to a supermarket, anybody and their mother goes to the supermarket. So it's very random, the population that you have at that supermarket. You could get people that love football, that love your school, that hate your school. You are going to have the most random sample with no bias or less bias at a supermarket. And the last option, I just want to read it to make sure that we don't have a good alternative here, is the high school band concert. So again, you're dealing with something related to the school, just like the school fundraiser. Again, it's not related to football necessarily, but it's related to the school, and so usually you care, again, about your school. So the most random sample with limited bias to give us the best estimate for the proportion of registered voters would be the supermarket. Flip it over and we've got 3 more questions. Alright, question number 4. A researcher randomly divides 50 bean plants into 2 groups. So randomly into 2 groups. He puts one group by the window to receive natural light and the second group under artificial light. He records the growth of the plants weekly. Which data collection method is best described in this situation? So we've got an observation, we have a controlled experiment, a survey, and then something called a systematic sample. So if I'm just purely looking at data and I'm not intervening, I'm not assigning to particular groups, and it may or may not be random, then that's an observation. But I forced them to either get natural light or artificial light, and it was random. So that automatically tells me that I have a controlled experiment. Survey is also out because the survey is when you're asking questions and then looking at the data, and clearly we didn't ask these bean plants any questions. Question 5 says an orange juice processing plant received a truckload of oranges. The quality control team randomly chooses 3 pails of oranges, each containing 50 oranges from the truckload. Identify the sample and the population in the given scenario, and then state one conclusion that the quality control team can make about the population if 5% of the sample was found to be unsatisfactory. So you've got a truck full of oranges. If you want to think about what your truck looks like, it's full of oranges, right? Lots of them. And then you're taking buckets of them, 3 pails of them, and each one has 50 oranges. So your sample here is the smaller portion of the whole population. So in this case, our sample would be the 3 pails of oranges. And again, there's 50 in each. And then our population would be the place that we took those samples from. And in this particular problem, we're taking it from the truck. So this is the truckload. And then to state one conclusion, well, if 5% of our sample was found to be unsatisfactory, meaning poor or bad, then our population must also have 5% that is unsatisfactory. So we can state that the population would likely also have 5% to be unsatisfactory. And then we have one more question. It says, describe how a controlled experiment can be created to examine the effect of ingredient X in your toothpaste. So remember, an experiment has 2 groups, and those groups have to be randomly assigned, and then usually there's a control group that might not have the ingredient in it, while the other group would possibly have would have the ingredient in it. So what I would say is randomly assign people to TWO groups, where one group receives toothpaste with ingredient X, and the other group receives toothpaste without ingredient X. Take a minute to write your summary. Think about what you can say about observations versus an experiment versus a study. And then also think about what you could say about bias. How can you create a non-biased sample? If you have any questions, of course, let us know, but we have practice problems to do and then a see-up. You have a good day, guys.